right, guys, how we doing? We're going to talk a little bit about a love story that started, kind of what I tell people when we start talking about this is picture this, Sicily, 2015. All right, that's a Golden Girls joke for those of you who are too young to get it. But the reality is it was the FCC in 2015. We talked about CBRS. All of us got excited. I was one of them. I'll be the first one to tell you. I was like, yes, finally something that solves all these problems in Wi-Fi. We're going to fix all these problems that we have. We're going to fix all these things that don't work right? Everything under the sun from QoS. 4 times the range, 4 times or 11 times the distance, or 11 times the capacity. We had all these things we were going to be able to do. It didn't work out, right? Because it was 2020 before we actually started seeing the products, and we got really excited again, and it didn't work out. Why? It's been 84 years, right, Hubie?
Yeah, it's been a while.
84 years. Check the next slide. There she is. It's been 84 years. Since we started talking about more coverage, since we started talking about better latency and throughput, since we started talking about some interference-free spectrum, which we all found out, it's not exactly right. But it was the holy grail. We thought it was going to be something that really, really worked out well. And there were a few reasons we figured out, why is it that nobody jumped on it? And I mean, some people did, right? I mean, I've got plenty of customers that went that way. But a lot of people didn't, and they haven't. So I'm going to give you guys 3 reasons why people did not jump on the private LTE train. Of course, we started calling it CBRS, and then all of a sudden, all of you guys in the room that are really smart went, no, that's not what that is, because in other parts of the world, it's not CBRS, right? It's still private LTE. The first reason is devices, right? Because when it came out in 2015, it was 4G. By 2020, we still had a buttload of 4G devices out there. Now today, most people want 5G if they're going to deploy private LTE, which is a lot more expensive, by the way, if you haven't looked at some of it. But that's a problem. Because, I mean, if you look in the spaces where it really matters most, which is on the next slide, in the spaces where it really matters most, there's only like 2 or 3 devices still today in the 5G space that work in that space. But the other problem, I blame you for. It's all your fault. You made the Wi-Fi too damn good. And that is actually part of the problem in getting people to consider private LTE. What if good enough is good enough, right? Good enough is always the enemy of great. And private LTE for us was an opportunity to be great at certain things. And we talk about very specific network use cases. We talk about autonomous ground vehicles, for example, which I don't know, stop when connectivity fails. So that's a problem, right? We talk about push-to-talk. We talk about automated machines in manufacturing. Anywhere where you've got concrete floors, metal walls, and things moving around all the time. Warehousing is another great example, like they were just talking about when they were up here at Ekahau. So in-vehicle connectivity, why isn't everyone using it? There's one last big reason, and this is the one we're going to talk about, how we fixed it. Okay? And again, no vendor BS up here, just saying it can be fixed. And this is the last reason why people aren't buying private LTE to go with their cellular networks. Now, if you've heard Greg Kamer up here talking, he's a good friend of mine too, and he talks about how private LTE is not your enemy. It's not. Private LTE is a solution to a problem. And for the last, what do we call it, 2, 4 years? It was a solution looking for a problem. Yeah. But, right, I see a lot of heads nodding. So yeah, that was exactly what we were all calling it. But today, it is a solution to a problem. We've got it. We got it sorted. And that last problem was converged networking, right? The reason these guys aren't jumping on it is because it's a completely separate network architecture. And when we started talking about it, right, Hubie and I talked about this all the time back in our Ruckus days, it's going to deploy just like Wi-Fi. Man, we were liars. Yeah. We didn't mean to be. We didn't know we were lying. We were just stupid. We thought it really would. And today, it does converge, and it does come together, and we're doing it for a live account, and what is it, Hubie?
19 sites?
19 cities.
Yeah, 19 cities.
19 cities.
And 19 different cities.
Yeah, so 19 different cities that we're now converging private LTE and wireless networks to deploy just like that. So why don't you talk about that a little bit and tell these guys how this works.
Yeah, so what we had, we'll go back a little bit back in history. Everybody remembers when we had APs and switches and we had to touch every one of them. That was awful. And then we had controllers came along, but it was still just APs. Finally, we got switches on board, so we could do everything. So we're there. We've got, for the enterprise side, and we're going to talk about network automations as well. We've even got network automations for the enterprise networks. Oh, not. Okay. So we've even got automations for enterprise networks and the United Enterprise Networks. Then we brought in LTE. Again, that's what we're talking about. So LTE's got a number of different things that we have to worry about. We've got device management, SIM management. You've got the packet core that's in there. And a lot of times it's going to be on the same infrastructure you've already built. So what we need is we need that converged network automations platform, just like we already have today for wired and wireless Wi-Fi stuff. You know, so if we have a client come in and they're on the LTE RAN or they're on Wi-Fi, we know where they're at. We've got them as a client. They're on there. They're on a VLAN. We can control. We can do policies and stuff like that. We can, on the automations platform, you know, you want to be able to, you know, have multiple uplinks. You want to have a router on there. You want to have all of the stuff that you've got today. You just want to put the LTE network in that same type of automation system. So we're actually, this is what we were talking about. This is the live system that we're working on. So on that automations platform, there's a hypervisor. And what you see here on that hypervisor is you've got the enterprise network controller already doing the same stuff that it's doing with the APs and the switches now, but we add in the Evolved Packet Core, 5G core. And that is communicating with the RANs, the LTE RANs. And it's also working as a VPN concentrator because everything that you do with LTE goes across an IPsec tunnel. So on this one platform, we're standing that up. We're hosting it. We're the VPN concentrator for all of that. And if you look down in the corner down there, there's an MNO/NH. That is the MNO interconnect and neutral host system. That is one of the biggest changes that we've had in this. So not only can we host all of this stuff, be the VPN concentrator for all this, to actually get the RANs and the clients on, now you've got that MNO interconnect that gives you neutral host. That was one of the things that stopped that. But with this automation platform, all the stuff that we're already doing today with wireless networks and wired networks, you know, Wi-Fi and wired clients, we're going to be able to do with LTE clients. So if a person's on, if they're on the LTE interface or if they're on the Wi-Fi interface, it's the same client. We can put them in VLANs, things like that. You know, all of our policies and all that type of stuff can be enforced, just like, you know, we would with a wired or wireless Wi-Fi client. Also, you know, if you look at stuff like LPV, big, huge networks, what are we going to do? We're going to have everybody on Wi-Fi or we're going to have everybody on a DAS system. This gives you the control back for that so that you can say, okay, this is overloaded. We're going to send these applications this way, these applications this way. We're going to move these users over because this system is totally overloaded, or we're going to balance it out. So it really gives you the platform, that automations platform, to combine this. And this is where we're going. These are live. So this is just one. I have multiples of these. I got more than one customer asking me for this stuff. So it's multiple. So people are wanting to do the same thing because for the first time, the LTE stuff's viable. Like you said, you got use cases. I was a guy a year ago that would have said this is a solution looking for a problem. Now I see it. You know, it's out there. We got people that are asking for this stuff. So if you want to talk any more about it, we've got other people from RGNets. Alec Murray is actually the guy that built this. So he's the guy that's working on this every day. Grab him, talk to him. Anybody else from RGNets can talk to you about this. Just ask us. So this is real for the first time.
I got a question for you.
Yeah.
So what's the benefit of having a localized EPC that is localized to each individual site but shared across sites?
Yeah, so the localized EPC, obviously, you got your traffics that are local, and then when you've got them across shared sites, if you're going to roam from site to site, and this system's actually going to be set up that way, so there's tunnels from site to site, so anytime you make changes to the databases, the SIM management or anything like that, it disperses that across the whole network, just like a cellular network does today. So if you leave from this site and you go to that site, all of your stuff's still there. So you're still there. You're still the client that system recognizes.
There you go.
Yeah.
Ladies and gentlemen, thank you very much.
Yep.